welcome back to another GCSE physics video. This one is on background radiation and contamination. So, background radiation comes from many sources. The background radiation that we're talking about is the low-level radiation that's around us all the time. You should always measure and subtract the background radiation from your results to avoid systematic errors it comes from. Radioactivity of natural occurring unstable isotopes, which are all around us, for example in the air, in food, in building materials, and even in the rocks under our feet. Radiation from space, which is known as cosmic rays, these come mostly from the sun. Luckily, the Earth's atmosphere protects us from much of this radiation. Radiation due to human activity, for example fallout from nuclear explosions or nuclear waste, but this represents only a tiny proportion of the total background radiation. The radiation dose tells you the risk of harm to body tissues due to exposure to radiation. It's measured in sieverts, SV. The dose from background radiation is small, so millisieverts are often used. Your radiation dose varies depending on where you live or if you have a job that involves radiation. Exposure to radiation is called irradiation. Objects near a radioactive source are irradiated by it. This simply means they're exposed to it. We're always being irradiated by background radiation sources. Irradiating sometimes does not make it radioactive. Keeping sources in lead-lined boxes, standing behind barriers, or being in a different room and using remote-controlled arms are all ways of reducing the effects of irradiation. Contamination is radioactive particles getting into objects. If unwanted radioactive atoms get onto or into an object, the object is said to be contaminated. For example, if you touch a radioactive source without wearing gloves, your hands would be contaminated. These contaminating atoms might then decay, releasing radiation which could cause you harm. Contamination is especially dangerous because radioactive particles could get inside your body. Gloves and tongs should be used when handling sources. To avoid particles getting stuck in your skin or under your nails, some industrial workers wear protective suits to stop them breathing in particles. The seriousness of irradiation and contamination depends on the source. Contamination or irradiation can cause different amounts of harm based on the radiation type. Outside the body, beta and gamma sources are the most dangerous. This is because beta and gamma can't penetrate the body and get to the delicate organs. Alpha is less dangerous because it can penetrate the skin and is easily blocked by a small air gap. High levels of irradiation from all sources are dangerous, but especially from ones that emit beta and gamma. Inside the body, alpha sources are the most dangerous because they do all their damage in a very localized area. So contamination rather than irradiation is the major concern when working with alpha sources. Beta sources are less damaging inside the body, as radiation is absorbed over a wider area and some passes out of the body altogether. Gamma sources are the least dangerous inside the body, as they mostly pass straight out. They have the lowest ionizing power. The more we understand how radiation affects our bodies, the better we can protect ourselves when using it. This is why it's important that research about this is published. The data is peer-reviewed and can quickly become accepted, leading to many improvements in our use of radioactive sources. And that's the end of the video.